5.5, 5.6, and 5.9. These are all little pieces of things to finish up this chapter for us. Part of it is the theorems of algebra, and in a small little portion is a review of the transformation of polynomials. With the theorems of algebra, we'll be talking about the factor theorem and the rational root theorem. And so the factor theorem states that a factor of a polynomial exists if and only if replacing x in the polynomial with the 0 of the factor results in that polynomial equaling 0. I should say equaling. Oh my gosh. Anyway, so in other words, x minus a, if that's a factor, that it's only a factor if and only if, and that's what IFF is, if and only if, that when you plug in whatever number you have here for a into your polynomial, that it results in the polynomial becoming 0. All right, so for example, you have f of x is equal to x cubed minus 7x plus 6. We want to know if f of 1 is a factor. So what you're going to do is you're going to plug in a 1 for the x's in your polynomial to see if it equals 0. When we do that, we plug in 1 here, and that's 1 cubed, which is 1, minus 7 times 1, plus 6. So that's 1 minus 7, which is negative 6, plus 6. That does equal to 0. So that means that since 1 is a 0, the factor would be x minus 1. From there, the whole point of this is to see if we can find the rest of the factors. So if we know 1, we can use the synthetic division to find the other ones. So we'll go ahead and set that up. So remember when we're doing synthetic division, let me get a different color, that you're going to use the opposite, or solve this for 0. Opposite of negative 1 is 1. And that's in the box. And then you take your coefficients, and remember you have to have every degree represented. If you don't, make placeholder. So this is, the coefficient is a 1 for the cubed. Do we have a degree of 2? No, so I need to put a 0. And then the degree of the 1 is negative 7. And then the constant is 6. Draw your line, bring down the first number. So that's going to be a 1. Then you multiply 1 times 1 is 1. That goes there, and then you add. 0 plus 1 is 1. 1 times 1 again is 1. And then you add. Negative 7 plus 1 is negative 6. Then you multiply 1 times a negative 6, which gives you negative 6. And then remember, the last part is always your remainder, which this happens to be no remainder. Then when you write your polynomial, it is going to be 1 degree less than what you started with. We started with a cube, so we're going to end up with a quadratic at the end. So it'll be 1x squared plus 1x minus 6. Okay, and then you can factor this, so that will become factors of 6 that subtract to be 1, that's 3 and 2. You have x, and then we have opposite signs, but the biggest number has to be a plus. So that'll be a plus, and that'll be a minus. And then, of course, x minus 1, don't forget that. That is also a factor. So this completely factors to make the x cubed minus 7x plus 6. So using synthetic division will help you find all the factors if you can figure out one of the factors by plugging in and seeing if it will make 0. So one way of doing it and using synthetic division, so you plug it in and see if it works. All right, the next theorem states that this is the rational root theorem, and this is a way to find possible rational roots, okay? So the possible roots, the way we find it is you take the factor of the constant term and divide it by all the factors of the leading coefficient. Now this could be several different ones. Now again, because of the degree of the polynomial, that's the most roots that it can have, but we are trying to find all the possible ones so we can eliminate it, so we can easily narrow down what we need to divide by to find the rest. All right, so we take the factors of the constant term. This is our constant term. What multiplies to give you 2? 1 and 2. Now, these have to be positive and negative answers. Every one of these needs to be a plus minus, okay? And then you divide that by the factors of the leading coefficient. Leading coefficient is the number in front of the biggest x degree. So that is a 1, so the factors of 1 are plus or minus 1. And then you take these, and whatever these numbers are, you have to find all the possible roots. If it had been a 2 or something, you'd have 1/2, and you would divide each one of these out by whatever's on the bottom. So you have 1 over 1, which is 1, 2 over 1, which is 2, and they're plus or minus. So there's a possibility right there of 4, okay? 4 possibilities, but we know at most it can have only 3. All right, so then we're going to try one of these to see if we can get the polynomial to equal to 0. So if we try plugging in 1, it will become 1 cubed, which is 1, minus 3 times 1, which is negative 3, plus 2. So that ends up being 1 minus 3 is negative 2 plus 2. So that makes plugging in a positive 1 to make a 0. So that means the factor would be x minus 1. And then you take that factor and you go ahead and you do your synthetic division to find the rest of your factors or your roots, whichever one they're asking you for. They're the same thing. Roots, factors, all the same thing. Okay, so let's look and see. Our coefficient is a 1, and that's a third degree. We don't have a second degree, so we have to put a 0. We have a first degree, that's a negative 3, and then we have our constant of 2. Draw a line, bring down the first one. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 3 minus 1 is negative 2. Negative 2 times 1, negative 2. And this is our remainder box, and we don't have a remainder again. So remember, it's 1 degree less, so that's going to be x squared, 1x squared, if you need to put that, plus 1x minus 2. All right, see if we can factor this. Factors of 2 that subtract to be 1, 2 and 1. All right, x and x, and we know that it has to be different signs because there's a negative in the back. We look at this and it has to be a positive 2. Negative 1, and don't forget our other factor we took out, x minus 1. So this is our complete polynomial factored out right here. Sorry, I'm writing crooked. That means that x minus 1 has a multiplicity of 2 because it's repeated twice. So you could write this actually x plus 2, x minus 1 squared. Okay? So this has a multiplicity of 2, which means if you were to graph this, it's going to bounce off of 1. And if you have this at negative 2, the multiplicity is 1, so that means it's going to go through negative 2, but bounce off of positive 1 when you were set this up. Okay? So you take your constant term, find all the factors, take the factors of the leading coefficient, that has to be division just like this, and then you find all your possibilities, check one of them to see if you can find a 0, and then divide out, and you should be able to get the rest of them. And the last little piece is transformations. Transformations we've already covered, but we're just going to look at it from another type of graph, which is a cubic. Again, it's a description based on the polynomial shift from the parent graph of a polynomial function. Okay, so a cubic parent graph would be f of x is equal to x to the third power. All the parent graphs are their basic form. And then I want to describe and or graph the function -2 times the quantity of x plus 3 cubed minus 1. Well, to describe it, you look at what's going on with each little piece. This negative in the front, right here, makes this do a reflection, which means it flips it around from positive to negative direction. Okay, then you look inside the parentheses and we have plus 3. That's the horizontal shift, but remember it's always backwards from what's in the parentheses, so it's going to be a shift to the left. Okay, 3. Then we have a -1 on the back end. That is the vertical shift, and that would mean it's going down. So the parent graph of an x cubed looks something, let me change my color, you won't be able to see it at all. Alright, it's going to go through the origin, and it's going to go in a manner similar to this. Whoa, wait a minute. Sometimes it's easier not to start in the middle and graph it. But the main thing is the parent graph goes through the origin. Okay. Whoa. Hold on. I'm just going to start it not through the middle. Like that. Much better. Okay. It's going through the origin. And it's going in the positive direction, left, right. Right, now this one is going to be a reflection, and if it's looking this way, a reflection means it's going to go down, up. Okay, and it's going to have a stretch of 2. It's going to be shifted down 1 and over to the left 3. So I'm going to go over to the left 3, down 1. That's where it's going to start. And it's going to be going at a stretch of 2, but in the opposite direction. So whereas this one kind of spreads out really nice and smooth, it's going to be a sharper turn. More like that. Okay? A little bit sharper than that. Hold on. Something like that. Shift over 3, down 1, there's my dot. There you go. Similar to that. The gist of it is that you know that it is an S-shaped curve and you know how to shift it. You can also solve these. If you wanted to solve these, you would set it equal to 0, move the 1 over, divide by a -2, and then take the cube root, because it's cubed, of both sides. So that way you would get some of these imaginary roots and terms, okay? But the main thing is just know how to shift those again. We have the same situation we had before with the quadratic forms and the lines and different things, but this is just a reminder of how we did it before. So if you have any questions, come see me in class. This should be a very simple section for you, and I will see you in school.